Let's try to solve this problem here. So it says that the figure below shows 2-point charges, Q1, which is 6 nanocoulomb, and Q2, which is negative 8 nanocoulomb, and they are placed at X and Y respectively, and are separated by a distance of 2 cm. So position X and position Y, the distance between them is 2 cm, and at position X, you place a charge called Q1, which is 6 nanocoulomb, and at position Y, you place another charge Q2, which is negative 8 nanocoulomb. So now the question asks, what is the electric field strength caused by Q1 at Y? Okay, so what happened here is Q1 is positioned at X, but Q1 is a point charge. Therefore, it will produce an electric field around position X. Okay, around Q1 or around position X, there will be an electric field that is produced by point charge Q1. And position Y is a position that is around position X. Therefore, position Y should also have an electric field that is produced by Q1. Okay, so at position Y, there is an electric field produced by Q1. At position X, there is an electric field that is produced by Q2. Because Q2 is a point charge, therefore it will produce electric field around the point charge. So point X is a position that is around point charge Q2, therefore position X should have an electric field that is produced by Q2. Okay, so you have to be very clear what produces what. Okay, the electric field at position Y is not produced by Q2. The electric field at position X is not produced by Q1. Okay, so you have to be very clear what is producing what at what position. Okay, so let's try to draw a diagram to illustrate the idea first. Okay, so we have a position X and we have a position Y. Okay, position X and position Y, the distance between them is 2 cm. Okay, so now because you place a point charge Q1 at position X, let's label it in green, because you place a point charge which is 6 nanocoulomb over here. What happened here is the surrounding of Q1 will have an electric field that is produced by point charge Q1. So because position Y is a position that is around point charge Q1, therefore position Y should have an electric field caused by Q1. And since Q1 is a positive point charge, the direction of the electric field at position Y should be pointing directly away from the point charge. Okay, it's a positive point charge, so the direction of the point charge should be pointing directly away. So for Q1, I'll label it in green. So this is the electric field produced by charge 1. Okay, so let me remove the irrelevant stuff. So at the same time, right, at position Y, it's not empty there. We put something over there actually. So what we put over there, we put Q2 at position Y, and Q2 is a negative charge. Okay, so because Q2 is being positioned here, so around this position Y, there will be electric field that is produced by this Q2 over here. So since position X is a position that is around point charge Q2, position X should also have an electric field that is produced by Q2. And since Q2 is a negative charge, the electric field produced by Q2 at position X, it's pointing towards Q2. Because Q2 is a negative charge, the electric field produced by a negative charge point towards the negative charge. So this is the direction of the electric field that is produced by charge 2. Okay, so you have to be very clear. Do you see that? Wait, let me remove the irrelevant stuff first. Okay, so do you see that the E over here belongs to Q1? It is Q1 that produced the electric field over here. It's not produced by Q2. On the other hand, at position X, the electric field over here is produced by Q2, not produced by Q1 that is placed at that position. Okay, you can only create an electric field around the point charge. You don't create an electric field directly at the position of the point charge. Okay, or else the electric field will react with itself, then it will exert a force on itself, which doesn't make sense. Okay, the electric field must be produced around the point charge, not directly at the position of the point charge. Okay, so this is the situation we are in now. So they ask what is the electric field strength caused by Q1 at Y. So let me do this. Okay, so they want the electric field strength. Electric field strength, occasionally you see people say electric field strength is the magnitude of the electric field. But occasionally, electric field strength also includes the direction as well. So in here, I will try to determine the magnitude and the direction as well. Okay, so the electric field caused by Q1, you can calculate using K Q1 over R squared. Okay, since there's only one R over here, which is the distance between position X and position Y, so we don't need to specifically label it as R1 or R2. Just leave it like that, will do. Then I put a modulus here around Q, because the E over here is the magnitude of electric field. Magnitude of electric field means that it must be a positive value, so you shouldn't have any sign for your Q over here. Okay, so you substitute in your value. Okay, then Q1 is 6 nanocoulomb. You don't substitute in the sign. Then R is the distance between position X and position Y, which is 0.020 meter squared. So if you calculate, I believe you get answer 1.35 times 10 to the power of 5 Newton per Coulomb. Okay, this value here must be a positive value because we already modulus the Q already. So means by the Q should not have any positive or negative sign. So K is a positive value, Q is a positive value, R is a positive value. So E should definitely be a positive value. What are we calculating here is only the magnitude. We are not considering the direction here. So if you want to consider direction, you look back to your diagram, see what your diagram is labeling over here. And since it's pointing to the right, so if you want to express the magnitude and direction, you express it in vector form, saying that the magnitude is 1.35 times 10 to the power of 5 Newton per Coulomb, and direction, you can say it's to the right. Okay, so that will be E1. That's the magnitude of the electric field over here. This is the direction of the electric field over here. It's pointing to the right. Okay, continue. Question 2 asks is what is the electric field strength caused by Q2 at position X? So again, Q2 here, Q2 is over here. Q2 will produce an electric field around position Y because Q2 is placed at position Y. So there will be electric field around position Y. So position X is a position that is around position Y. So position X will have an electric field produced by Q2. Okay, so we label this as E2. Okay, this is the electric field strength produced by Q2. Okay, you can label an E2X also okay at position X. If you want to label an X over here, that's fine as well. Okay, so this one is KQ2. Remember the modulus R squared. Okay, so if you perform your substitution, Q2 will be negative 8 nanocoulomb, but you don't substitute in the sign, you just take the value, the absolute value only. Okay, R is the same, 0.020. Okay, so if you calculate it, I believe the answer you get will be 1.80 times 10 to the power 5 Newton per Coulomb. So if you express it in terms of vector, then you include the direction. And 1.80 times 10 to the power of 5 Newton per Coulomb. Again, this one is to the right. Okay, so do take note of the way I express my symbols. Over here, when I'm doing my calculation without considering the direction, what I'm doing here is the magnitude. So if I'm doing a magnitude, there should be no vector sign above my E. Okay, but when I want to express my magnitude and direction together, then I only express it in terms of vector. So do notice that where I put my arrow, I don't put an arrow for magnitude. I put an arrow only if I want to include the direction in the form of a vector. Okay, so this is how you solve this problem. If you want to continue, right, this is how you can think about the situation here. Okay, you can think that so first thing happen is Q1 produces an electric field at position X. Okay, and you happens to know that this electric field produced by Q1 is 1.35 times 10 to the power of 5 Newton per Coulomb, and it's pointing to the right. Okay, a continuation of what you can think is, since you see that Q1 is producing at position Y, what am I doing? Q1 produce an electric field at position Y, not position X. It's my bad. Okay, Q1 is placed over here, so around Q1 there will be electric field produced by Q1. So position Y is around Q1. So position Y we have an electric field produced by Q1. So continue. You see that Q2 is positioned at Y. Okay, Q2 is now positioned at Y, and there is an electric field produced by Q1 at Y. Okay, so therefore, okay, this is how you should think about the situation. Therefore, Q2 will interact with the electric field produced by Q1. As a result, what's the result if a charge is interacting with an electric field? As a result, the charge, which is Q2, will experience a Coulomb force. Okay, this is just to help you think about how the process happened. Okay, so if they ask you to find what is the magnitude and direction of the Coulomb force experienced by Q2, then what you can do is you can find the magnitude using F equals to Q2 times E1. This is the electric field produced by Q1. Then Q2 interact with the electric field. Okay, electric field is produced by Q1, but Q2 interacts with it. Therefore, Q2 experience the Coulomb force. Okay, I hope you are able to see what is the one producing electric field, what is the one interacting with the electric field, thus experiencing a Coulomb force. So this is how you determine the magnitude. You can do it yourself. You want to determine the direction, look at the charge. If it's a positive charge, then you know that the force and the electric field are in the same direction. Okay, so in this case, if it's negative, then the force and the electric field are in opposite direction. Okay, so if you look over here, Q2 is the one that is experiencing the force. So Q2, it's a negative charge, it's negative 8 nanocoulomb. So since Q2 it's a negative charge, the force and the electric field are in opposite direction. We know the electric field at this position is pointing to the right, so the electric force experienced by Q2 will be pointing to the left. Okay, so if you think about it on the other side, at position X, there is electric field that is produced by Q2. So Q2 produces an electric field at position X. So position X, there's Q1 placed over there. So it's because Q1 is placed over there and there's electric field produced by Q2 over there at X, what will happen is Q1 will interact with the electric field produced by Q2 at X. So after the interaction, Q1 will experience a force, experience a Coulomb force. Okay, the magnitude also can be calculated by this, but since this force is experienced by Q2, so this one will be Q1 interacting with it, and this is electric field produced by Q2. So you have to be very clear what you substitute it here. Q over here is the one that is interacting with the electric field. E here is the electric field that is produced by something. Who is producing the electric field over here? Then F here is experienced by the charge that you place over here. Okay, for the direction, since Q1 is a positive charge, so because it's a positive charge, the force and the field are in the same direction. So since the field is pointing to the right, the force experienced by Q1 should be pointing to the right as well. Okay, that's a whole picture of the situation. Sometimes I call it a two-stage process. One charge produce an electric field, another charge interact with the electric field. So we call it a two-stage process as well. But I hope you, through this example, you are able to see clearly what is producing the electric field, what is interacting with the electric field. Okay, so that's all for this question.